Hi guys, today we are going to talk about ions and then we will talk about type 1 binary ionic formulas. So let's talk about what you should be able to do and what you should know. Some vocab: ions, valence electrons, octet rule, charge or oxidation number, cation, anion. We're going to learn about those things. Skills: you should be able to tell me how many valence electrons an atom needs to gain or lose to become stable. You should be able to write the ion formed when valence electrons have been lost or gained. You should be able to classify an ion as a cation or an anion, and you should explain how these cations and anions are formed. So I'm going to teach you all that, and you'll be able to do all that. All right, so this ion is an atom that has gained or lost one or more valence electrons and has a positive or a negative charge. So if you've got, let's say, here's your outer shell, and you've got one electron sitting out there. If you lose that electron, it's going to become an ion, or if you gain another electron, it's going to become an ion. And it can be more than one electron. You also need to know the octet rule. Oct is like octopus. This means an atom needs 8 valence electrons to fill its highest energy level, its outer shell, and to be stable. Except for helium, you've got to remember this, it's important. Helium only needs 2, so it's an exception. But all other elements or atoms are going to need 8 to become stable. They're going to do that through gaining or losing or sharing, and we'll talk about those later. Oxidation number is a fancy word for the charge of an ion. We'll normally talk about it as charge, but once in a while you might see the term oxidation number, and I don't want you to be confused. So it's the charge of an ion, example 1 plus or 3 minus. And I know some of you guys asked that. Can you write it this way, plus 1 or minus 3? Absolutely. I don't care where the plus or minus is, as long as it's there. All right, let's talk about how ions are formed. The first type of ion we're going to talk about is a cation. Okay, a couple ways to remember that a cation is a positive ion. You've got the word cation, and the T looks like a plus sign, so positive ion. Cations are only formed from metals because metals are going to give away or lose electrons. Okay, so very important information about cations. They are positive, they are formed from metals, and they give away or lose electrons. Okay, so let's look at its electron configuration or Lewis dot structure and find out how many valence electrons it needs to become stable. And we can also look at it these as a we just said that, electron configuration. So let's look at, for example, calcium. All right, calcium's electron configuration is, let's just do its noble gas configuration. The noble gas configuration is actually argon, and then it is 4s2. Okay, so that means at its highest energy level, which is 4, it has 2 electrons. All right, what you want here, and let me write out its ground state. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So remember, it needs to have 8 electrons in its highest energy level. So it needs to have the same configuration as a noble gas. So in order to get back to a noble gas, 3p6 is a noble gas, that's its argon, we would have to drop 2 electrons. Okay, so in that case, we would totally get rid of the 4th energy level. And we would drop down to the 3rd energy level. And if you look here in the 3rd energy level, you have 2 and 6, so that's 8 electrons. Okay, when it drops those 2 electrons, it has a +2 charge, because now what this calcium has is it's got, and this is important, it has 20 protons, so positive protons, but now we've dropped 2 electrons. It had 20, now it has 18 negative electrons, so that leaves you a surplus of 2 plus. So you would write this cation as Mg2+. Okay? Now let's talk about anions. A way to remember that it's an anion's properties is it's a negative ion. So think about that as negative. So a negative ion, anions. They are nonmetals because nonmetals form anions, and they gain or they take electrons. Okay, so very important. Anions are negative, nonmetals, and they gain or take electrons. So again, let's look at its electron configuration or its Lewis dot structure. Let's look at electron configuration first. So let's look at the electron configuration for, let's say, fluorine. Fluorine is 1s2, 2s2, 2p5. So right now, looking at its highest energy level, which is 2, it has 7 electrons. 2 and 5 equals 7. So you have to think to yourself, is it easier for it to lose 7 electrons or just to gain 1 more to get to that 8 to be stable? Obviously, it's going to be easier to gain 1 more electron. Okay, so we've added an electron to it, plus 1 electron. So now let's talk about our charge overall. Let's talk about our charge. So what we did was we added an electron. Originally, fluorine had 9 protons and 9 electrons. We added an electron. So plus 9 and 10 minus gives you -1. So you will have fluorine with a 1 minus charge when it gains that extra electron to take this up to 6, in which case it would have the same configuration as argon. Another way to look at these is if we have, let's say we'll have fluorine again. Here's fluorine. It has 1, 2, 3, 4, 5, 6, 7 valence electrons. So our goal is to either fill that outer shell or to get rid of it and drop down to a lower energy level. Okay, so if we add 1 to this, okay, now we have that extra electron, so we have a -1 charge. Oops, sorry, I added it, but it went away. I don't know what happens there. Let's look back at the cation too. So let's look at calcium here. And calcium had 2 valence electrons. And what we do, it looks like it goes down to 0, but that's not what really happens, because going back to calcium, calcium looks like this. Here's its positive nucleus, and it has 1, 2, 3, 4 energy levels. In this outer energy level is where it has its 2 valence electrons. So there's 1, and here's 2. Okay, and here it's got its 1, 2, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that gives it a total of 20 electrons. So what happens is we lose these 2 outer electrons. When we lose those, it loses that whole energy level. So now it only has 3 energy levels because it's taking the formation of argon, which has 3, and it has its full valence shell of 8 electrons. So your Ca ends up having that 2+ charge. Okay? So that's how we can look at it with electron configurations or Lewis dot structures. Basically, they're gaining or losing electrons, gaining electrons if they're anions, losing if they're cations, and then they take on that plus or minus charge because they've lost them, because they have more or less electrons than they do protons now. All right. Take a break here because that was the end of first day's notes. I'm going to keep going into the second day's notes and post these together. So you can take a break, or if you're ready for day 2, the type 1 binary ionic bonds notes, just keep on going. So let's talk about these type 1 binary ionic bonds. Vocabulary you need to know by the end of this lesson. Binary, chemical bond, ionic bond, type 1 binary ionic bond. By the end of the lesson, you should be able to you should know the charges of the ions, write a type 1 binary ionic formula, and name a type 1 binary ionic compound. So let's talk about a little vocab first. First of all, a chemical bond. There are different types of chemical bonds. It's a force that holds two atoms together. We'll be talking about different types, such as ionic and covalent bonding. Those are two types. There's also a metallic bonding that we're not going to talk about. But an ionic bond is a type of chemical bond. An ionic bond is a bond in which electrons are transferred. That means that they are given or taken. This only occurs between metals and nonmetals, which are cations and anions. So you have to have, very important, you have to have a positive and a negative. Okay, so you've got a positively charged ion and a negatively charged ion that form an ionic bond. That's a metal and a nonmetal, or a cation and an anion. Type 1 binary ionic bond is between only two atoms. That's the binary. Okay, this is super important. It's between a positive representative metal. Now, a lot of you guys got that wrong on the test, even though it was in our notes and it was on your study guide. A representative metal is a metal from the S block or the P block. There's a couple of those like aluminum. Okay, so that's where those come from on your periodic table. S block and P block are representative elements. So it's going to be a metal from one of those and a non-metal from the P block. Okay, so it's a cation and an anion. So again, it's representative. We'll talk about a different type of binary ionic bond that involves a transition metal later. All right, let's look at how ionic bonds are formed. Let's look at something like, let's do calcium oxide. All right, so what we have here is we're going to use our Lewis dot structures or electron dot structures. Calcium has 2 electrons. Oxygen has 6 electrons. Oops, what did I just do? Why did I draw it there all weird? Okay, so calcium, to become stable, we know it needs to drop those 2 electrons and go to an lower energy level. Oxygen needs to gain 2 electrons to get to 8 and become stable. So what makes sense here is that calcium is going to give oxygen its electrons. So calcium is going to give oxygen 1 electron, and then it's going to give oxygen this other electron, which is going to fit in right there. So now calcium is going to be left with none here. Oxygen is going to be left with those 8, and they have formed a bond. Okay, so what you'll get there is you have 1 calcium atom, or calcium ion, and you have 1 oxygen. So what they do is they form a bond, and it's called CaO. That's the formula for it. Okay, let's look at another one of these. We're going to look at a couple of these so you guys really get the idea of how these work. Let's look at something like, let's do magnesium and fluorine. Okay, so magnesium has 2 valence electrons. Fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So how many does magnesium need to get rid of? It needs to get rid of 2 to become stable. How many does this fluorine need to take? Well, it needs to take 1 to become stable. So we can only work with magnesium fluorine. We can't throw anything else in there. So what we can do is magnesium can take this electron right here and give it to fluorine. And that's great. Now this fluorine has a full outer shell. It now has 8 electrons in its outer shell. That's fantastic. Oops, it disappeared, sorry. But magnesium still has 1 to get rid of. Can you think of what we might be able to do here? All right, what we can do is we can add another fluorine on here. So again, fluorine has 7 valence electrons. Magnesium still has this 1 to give. So it's going to go ahead and take this 1 and bring it down here to this fluorine. And now that fluorine's going to have 8 electrons. Magnesium now has nothing on the outer shell, so it dropped to a lower energy level. Each of those fluorines now have 8 valence electrons, so magnesium gave, fluorine took, and what we're left with here is Mg and 2 Fs, which we write as a subscript, magnesium fluoride. Okay, and let's just do one more for practice to see how this is done. So we are going to do, let's do aluminum and calcium. So we'll do calcium and aluminum. All right, calcium has 2 valence electrons. Aluminum has 5. Okay, so we know that aluminum needs 3, calcium needs to get rid of 2. So let's go over to the calcium here. It's going to get rid of both of those and give them to the aluminum. That's lovely. That calcium over here is stable because it lost those and moved down in energy level, but aluminum still needs to gain 1 more. The only thing we can do here is we can add a calcium. Calcium with its 2 valence electrons. Well, that calcium can give up 1 more valence electron because this aluminum only has spot for 1. Okay, great. The aluminum is now full. It has 2, 4, 6, 8 valence electrons, but the calcium's left with 1. So we're going to have to go ahead and add an aluminum. Get rid of that little guy before it gets in the way. All right. So this aluminum has 1, 2, 3, 4, 5. All right. This calcium has 1 to give. Well, let's give it up. Oops, I used the wrong color. Let's give it up over here to aluminum right there. Aluminum still needs 2 more to be full, but the calcium's dropped down in energy level, so it's done. We're going to add 1 more calcium with its 2 electrons, and we're going to go ahead. We can give 1 to the aluminum here and 1 to the aluminum here. Now, all of the calciums have dropped down to the lower energy level. All of the aluminums have gone up to 8 electrons, so everything is now stable. There should be 1 there. So let's count them. We have 3 calciums and 2 aluminums. So we just wrote that formula. Okay, so that's how we write in a binary ionic type 1 formula. But there's an easier way, and I'm going to show you guys that. On your periodic table, the one that you write on, you might want to write this down. Okay, it's a little rhyme. 1, 2, 3, skip, 3, 2, 1, zip, or 0. This tells you the charges or oxidation numbers of those 8 families, those 8 groups. Again, we are going to skip the transition metals like we did with valence electrons for this. Okay, so group 1 ends up with a +1 charge when they become an ion. Group 2 has a +2 charge. Group 3 has a +3 charge. Group 4, some of them have +4 and some of them have -4, so we're going to skip that group. So ignore that group. We call it skip. So we've got 1, 2, 3, skip. Now, in your nonmetals, group 15 has a -3 charge, 16 has a -2 charge, 17 has a -1 charge, and 18 has a 0 charge, or we call it zip. So you can memorize this super easily and know all your charges for all of these atoms. 1, 2, 3 going in the positive direction, skip. 3, 2, 1 going in the negative direction, and then zip, 0. So you've got to memorize that. It's going to help you a ton because that's going to be a shortcut so you don't constantly have to write out these whole Lewis dot diagrams to find your formula. Okay, so have your periodic table out with 1, 2, 3, skip, 3, 2, 1, zip on it. So plus 1, plus 2, plus 3, skip, minus 3, minus 2, minus 1, zip, 0. We're going to use something called the crisscross method. The crisscross method has us write charges for our ions. So as a superscript, let's talk about what a superscript is. If you have calcium with a 2 plus up there, that's your superscript. So your charge is written as a superscript. I think about it like Superman flies in the air, so a superscript is up above. Whereas a subscript would be down here. So that means we have 3 calcium atoms. Okay, that's telling us the number of atoms we have. So we write it down at the bottom. Subway is down at the bottom, so subscript is down at the bottom. So it's important to know the difference between those. So to show our work for this, for our crisscross method, what we do is we take the charges of each element in the compound. So we have sodium chloride. So we have sodium. And if you look at your 1, 2, 3 skip, 3, 2, 1 zip, sodium is in group 1 and it has a plus 1 charge. Ah, that's a terrible plus. Let me rewrite this. Okay. Chlorine is in group 17, and using your rhyme, it has a 1 minus charge. So what you do is you take the number from up here and you crisscross it and bring it down as a subscript. So what you would get here is you will get Na1Cl1. Those ones can actually cancel each other out. If you have the same numbers as your plus and your minus, they're going to cancel each other out. Another way to think about this is you want to get rid of them anyway, because in math, if you have an x that tells you it's 1x, you usually don't write a 1 in front of it. So let's erase all of this stuff. All right, so you would get NaCl for sodium chloride. Let's look at magnesium fluoride. Using your rhyme, magnesium has a 2 plus charge. Fluorine in group 17 has a 1 minus charge. So again, we're just going to take our number from up here and we're going to crisscross and bring it down as a subscript. So you're going to be left with Mg, which would have a 1 down here. But again, we're not going to write a 1, so you just don't write anything. F, we're going to bring this 2 down after it. So your formula is MgF2. So that's your crisscross. Let's do the same thing for aluminum sulfide. So aluminum, looking at your 1, 2, 3 skip, 3, 2, 1 zip, has a 3 plus charge. Sulfur, 1, 2, 3 skip, 3, 2, 1 zip, has a 2 minus charge. So again, take the number, crisscross. Okay, so this up here is showing your work. In the actual formula, you will not have charges, you will not have anything in the air, you will only have subscripts. Okay, so showing our work there, and then we're going to bring those numbers down. So the Al is going to get that 2 down here, and the S is going to get that 3 down here. So that is your formula for aluminum sulfide. Please pay really close attention to how a formula looks. Again, a formula doesn't have pluses or minuses in it. A formula has subscripts in it. Okay? Other than that, this up here is me showing you my work. Okay? All right, so that is how you write formulas. That's the cheating shortcut to writing formulas. Naming, let's talk about that. First of all, you name your first element, the metal. Then you name your second element, the nonmetal, but you change the ending to "ide." So have your periodic table, and let's look at this element or this compound right here. We know it's an ionic formula because it has lithium, a metal, chlorine, a nonmetal. So we simply write it out. Lithium, we write the name of the metal, its full name. Then we have chlorine. So having chlorine, what we do is we take the ending and change it to "ide." So it's going to be lithium chloride. That's the name of this binary ionic compound. Let's look here, MgBr2. Well, for binary type 1 binary ionic, we don't need to worry about the 2 because that is how we get the formula, so you don't have to worry about that right there. Again, we're going to name the first element, magnesium, and we're going to take the second element, which is bromine, and we're going to change the ending to "ide." So magnesium bromide. The last one, we have aluminum, keep its full name. Oxygen, we're changing the ending to "ide." So for this one, it's going to be oxide. Okay? So that part should be pretty easy peasy. Please contact me if you have any questions about that, and I will help you. It's so important that you do the practice along with this. For my Apex Digital kids, make sure you are uploading the practice to Apex and you are keeping up with this. Again, I cannot stress how important this is, and that you will not be able to move on in chemistry successfully without knowing this and the other names and formulas that we'll go over the next few days. Please, please, please take this seriously. And to my regular in-class kids, you also have to do the practice. Same stuff applies, but you'll turn yours in class. All right, guys, I hope you have a great day, and I'll talk to you all soon.